Hi, my name is Ayush Kochru, and this is my Lab 2 for Physics 2212 Lines of Charge. So, introduction. The purpose of this lab is to conduct an experiment with two positively charged pieces of tape. We observe the interactions between these pieces of tape to determine their charge. This is a continuation of Lab 1, and we used a closed-script model, or closed-script to create a computational model calculating the electric charge of the tapes. And the findings of this lab are that the charge of the tape is around 6.116 e to the negative 9 coulombs, and the magnitude of the force that the tape exerts on the other tape is 1.962 e to the negative 3 newton. So some of the models and fundamental physical principles used in this lab are Newton's second law, the gravitational force, and Coulomb's law. So the procedure. What we did is similar to the first lab, where we cut a 20 centimeter piece of clear tape and we folded back an end to make the handle. We put this tape on the desk, and then we repeated this process with a new tape, and we placed this on top of the base tape. Then we pulled the upper tape off of the base tape, which gave the upper tape some kind of charge. Then we test the interactions of the upper piece of tape with another U-tape, and then we tested this U-tape with with a negatively charged pen as well. The procedure continued as we stuck a U-tape on top of two objects, and then we put another tape underneath it, and then we moved the tape that was underneath the top tape closer until the top tape repelled the bottom tape, and then we measured the distance where the repelling began. The assumption in this lab is that we can ignore air resistance on a moving object. We can assume that the charge is equally distributed along the tapes. We assume that each U-tape has the same amount of charge. Tape B, which is the upper piece of tape, has no net force when it's floating, and we assume that the forces acting upon tape B are gravity and the electric force from tape A. The system initial values, the system at the top piece of tape, which is tape B, the surroundings is the bottom piece of tape, which is moved towards tape B, which would be tape A, and also the Earth. We said that tape B, the system began at rest. That should say tape B. And the force of gravity is the negative of the electric field, of the force of the electric field, because then the force is 0 in our case. And then I have listed the length, width, mass, and the force due to gravity of the tape, along with the initial separation. So according to the rod model of electric charge, if we can assume that the radius is much smaller than the length, we can use the formula. Field of rod is K times 2 times charge divided by length divided by radius. And when we plug in radius and length, we can see that the radius is much smaller than the length. And so once we find, we know that the electric field of rod is that charge Q times 3.6 e to the negative 13. And from the previous slide, we know that Fg is 1.96 e to the negative 2. And so using this, we can set this equal to Fe, and then we can rearrange to solve for Q, getting a value of 2.33 e to the negative 9. Here I have listed the computational model for finding the electric charge that I used on ClosScript. So on the left I have the electric field function, on the right I have the function to find the electric charge, and on the top I'm initializing the charges for the top and bottom. This next slide, this is continuing to find the electric field and the electric force at each location, and then finally finding the vectors for each tape charge. So finally, we see that the magnitude of the gravitational force is around 1.96 e to the 9 coulombs, and then we used a charge Q of 6.116 e to the 9. So in our model comparison, the rod model had a charge of 2.33 e to the negative 9 coulombs, or negative 8 coulombs, and the ClosScript model had a charge of 6.116 e to the negative 9 coulombs. And from this, we see that the rod model had a larger charge than the ClosScript model because the charge is more distributed in points along the tape. Some possible errors are that when measuring the separation distance, it was measured incorrectly, and that also when finding the mass of the tape, a provided expression was used instead of finding the mass directly. The conclusion: what if we model each tape as a single point charge, like the previous lab? Compare the values. So the point charge is 1.17 e to the 9 coulombs, and the line charge is 6.116 e to the negative 9 coulombs. So why do these estimates differ? They differ because the line charge model accounts for forces on the pieces of the tape, And the line charge model is most likely to be closer to the real value because you're taking the sum of charges instead of the charges collected at one single point.